Hello everyone, I am AI astronaut from Kanga, and this is the 5th episode of the Kanga University Podcast series. The title of this episode is, What is Blockchain and How Does It Work? We have a challenge regarding terminology, because blockchain and Bitcoin, these two words or expressions, are often treated as synonyms, but they are not. Bitcoin uses blockchain technology, but not every blockchain is Bitcoin. There are many other blockchains that do not use or are not related to cryptocurrencies, but more on that later. First, let's clarify what blockchain actually is. It's a technology used for storing and transmitting data. Essentially, blockchain is a database that has certain characteristics. In terms of qualitative features, the most important ones are that it is secure and transparent. We'll explain what security means shortly, but there's also a third very important feature. Blockchain does not require central control or any central system. Blockchain operates in a decentralized manner. Blockchain, when translated, is chain of blocks. So, what are these blocks then? A block is simply a packet of information, a collection of certain information, of course, recorded in digital form. When we talk about a chain of blocks, we are really talking about data being connected into a larger collection, which is this chain. What is also very significant is that this vast database, which is the blockchain, as I mentioned earlier, is not kept in any central registry but is divided among various users, intermediaries. This means that every person who has access to the blockchain, and let's recall that everyone in the world has access to the Bitcoin blockchain, can check the accuracy of the records in this database. Someone once said that blockchain is a very large notebook that anyone can freely and without cost read, on which anyone can write, but from which nothing can be erased, and this notebook is also indestructible. For my own use, I often think of blockchain as a database that operates worldwide, and everyone has access to it. Besides being unshuttable and unchangeable in terms of recorded information, it has another very important feature. It cannot be copied. Now, imagine a situation where we have a photo of our family on our computer desktop. It's very easy to make a copy of this photo and send it to someone via email or post it on Facebook. However, when I made a copy, I still have my copy of this photo. In blockchain, if we recorded a photo, such things are also possible, though not in the Bitcoin blockchain, but in other blockchains. If we recorded a photo, we cannot make a copy of it. At most, we can send it to someone, which means I would no longer have the photo. This also helps me understand or explain how blockchain works. But let's get back to more technical discussions here. As we said earlier, we have blocks and chains. Information about transactions is recorded in the block. If we're talking about the Bitcoin blockchain, we have recorded information about who made a transaction and when. We have recorded the specific date, specific time, and specific amount. Blocks are connected into chains, as I already mentioned, and now how do we know the order of these blocks? We use a mechanism where each subsequent block knows its predecessor. It can recognize it. Each block does not know its successor, but each successor can recognize its predecessor, and thus we can arrange these blocks in the correct order. What is the name of the first block? We might have mentioned this before. It is called Genesis, which from Latin means beginning, referring to the first book of the Bible, which is also called Genesis. This was coined by Satoshi Nakamoto. If we took a very wise dictionary now and read the definition of what blockchain is, we wouldn't understand a thing. For the record, for people who will listen to this podcast in 2286 and will write articles about Kanga, I will read such a definition, but I'm doing it solely for archival reasons. According to the dictionary, blockchain is a distributed database that contains an ever-growing amount of information, records grouped into blocks and linked in such a way that each subsequent block contains a timestamp indicating when it was created and a link to the previous block, being an encrypted summary of its content. This summary is called a hash. I admit that to understand this definition, one needs at least 3 doctorates, but as I said, I'm reading it for archival reasons. In reality, the operation of blockchain is not complicated. It may seem so, but it is not. Let's repeat once again. It is a distributed ledger, a distributed database that records data in packages called blocks and links these blocks into a single whole. Since one block can have one predecessor and one successor, it cannot branch out. Hence, we speak of a chain, and that's how it looks. As we mentioned earlier, we do not have a central server. There are many computers worldwide that store information about all these transactions, all these blocks, and we call these computers network nodes. New information about new transactions keeps entering each block. How is it that false information does not appear in this block? This happens because every piece of information, every transaction that enters a block before the block is closed, is verified. The verification process is very complex and is carried out by people or organizations we commonly call miners. Depending on which blockchain we are dealing with, the verification mechanism is different. The 2 most common verification mechanisms are proof of work and proof of stake. In Polish, this sounds quite strange, but these 2 consensus algorithms, as they are technically called, are very common. In Bitcoin, we use proof of work. We can ask at this point, is blockchain as such secure? And here I can say there are 28 reasons or more. Why can we say blockchain is secure? Allow me to list 2. Firstly, when you conduct a transaction on the Bitcoin blockchain, you do not provide your name, your surname, your address, almost nothing. You approve or sign the transaction, but you do not provide your private data. Therefore, there is no fear that your data will leak somewhere someday, and someone will find out that you made a transaction on a specific date. We are familiar with all these scandals related to data leaks, whether from banks or other central organizations. In blockchain, we don't have this problem. And the second important argument confirming that blockchain is secure is that we cannot edit the data already recorded there. There is no possibility to cheat or change anything. Let's get back to the discussion on consensus algorithms, on these 2 most popular mechanisms of data, or transaction verification, proof of work and proof of stake. Proof of work, or work verification, is very energy intensive. It consumes a lot of electricity, which is often an argument against this transaction verification method, because miners using this consensus algorithm, which is the official, only working algorithm for Bitcoin, incur high costs associated with electricity consumption. Because miners bear these costs, they are rewarded for processing all transactions. Whenever you make a transaction based on the Bitcoin blockchain, you have to pay the miners who confirm this transaction, and every time a block is closed, the miners receive a reward that initially amounted to 50 Bitcoins. One block in Bitcoin is closed approximately every 10 minutes, so initially, miners who solved so-called puzzles, which means confirming these transactions, received 50 Bitcoins to share. Now it's 6.25, and in 2024, it will be 3.125 Bitcoins. This phenomenon of halving the reward from time to time is called halving. What is proof of stake? Proof of stake does not require such high energy consumption. Here, miners who confirm transactions or blocks must hold a certain amount of the cryptocurrency. For example, in Ethereum, if we want to confirm transactions, we must stake or freeze at least 32 ethers. The logic here is that no one who has staked or frozen such a large amount of cryptocurrency will want to introduce false data, because if they did, it would harm them and the entire community. The proof-of-stake mechanism is also complex and sophisticated, but here we can assume and explain it in this way that it does not consume large amounts of electricity. What are the advantages? Let's summarize this. What are the advantages of blockchain technology? Firstly, using blockchain technology, we can transfer cryptocurrencies. When using blockchain technology, we do not need third-party verification. The technology itself ensures that all transactions are carried out safely. We have complete decentralization. We do not store data about the location of the people making these transactions. Blockchain technology, as I have already said, is secure. Before any transaction reaches the block, it is confirmed by thousands, and some say even by millions, of computers worldwide. No country controls the blockchain, especially the Bitcoin blockchain, so everything is efficient, private, and secure. And that's it. If this episode seemed very complicated to you, don't worry. In future episodes, we will continue to explain everything. All the best. I invite you to listen to the next episode.